Good morning. There was some bleeding from the light above, so I'm thinking this might be a better way to go. Okay. And I guess with that, we're streaming. I'm going for the market of very early morning people who are interested in doing fast MRI. It's a large market, let me tell you. We currently have 0 watchers. Okay, great. Let's get started. You guys might remember we got the adjoint to work. This function that calculates the circular convolution of a and x. F of x equals circular convolution of a and x. So now it's time to do this. I don't know why MATLAB asked for this. We're back in SPIRiT now. We're doing recon SPIRiT, and really we're very close to having this up and running. We might get that up and running today. We certainly would if I had coffee, but I don't. Okay. What is the adjoint of that? Of course. Now I'm a little confused, actually. Did we get... So we got the adjoint of circular convolution 2 working when it was a 2-dimensional array. And it also works when it's a 3-dimensional array. How does that happen? I see. Okay, so this adjoint calculation is assuming that K also has 3 dimensions to it. Is that what happens here? I think it is. So if you have two linear transformations, A and B, and you're going to take their product, what is the adjoint of that? Well, it's B transpose A transpose. Or if it's complex, like we've got here, it's B Hermitian transpose A Hermitian transpose. So this is this. But before we do that, we have to do the adjoint of the sum operation. Ah. I think that's just, I'm going to change it to temp is equal to, just repeat the matrix. I want to check the adjoint. Oh boy. This is now giving me an error because I am now using C. Wait, I was always using C, so it must be either M or N that wasn't being used before, but now is. I don't always want to check the adjoint, right? So I'm going to set the code up to pass in a variable. What is, pass in a hidden variable that I will not put in the documentation, though I should probably do this. And only if it's set now will this check run, okay? Then right here, even though this is set to false and will always be, here, just for testing purposes, I'm going to set do checks equals to true so that this runs. And then I offset its indent. What? Huh. Okay, I offset its indent. And so later on, when I'm scrolling past here, this will annoy me. I'll remember that I don't need this, and then I'll delete it. That's the idea. Also, I'm not putting a semicolon here so that when it runs, this output appears, which will also annoy me and tell me to fix it. Okay. Does this run? Check W. It's true. It just worked. I didn't expect that. So you might say, why am I keeping this around? Didn't I just check it? Well, yeah, but I might change applyW at some point, and I want this thing to remember. I want this thing to still be available to check if the adjoint is still working. I posted on LinkedIn that I'm doing this, and one of my connections on LinkedIn, a guy named Wilder Lopez, who's a really neat guy, suggested that I set up a GitHub repository for this project so that if you wanted to, all 0 followers of you, oh, there's a follower. Oh my gosh. Oh, scratch that. The follower is my phone, which I use to make sure that the stream is still working, see if there's any chat going on. Okay. So anyways, I'll be doing that. Maybe we'll do that today. What have I got going on here? I'm very surprised that worked right out the bat. That never happens. I always have to debug the adjoints. Okay. Just to be sure. Check passed. Crazy. Oh, okay. Okay. So here I found the interpolation coefficients. Here we are going to use the interpolation coefficients. How do I know? Because I put these comments here. I don't use a lot of comments, obviously. I had it at the beginning, but you know, a lot of my codes don't have comments. Thankfully, I put these here and they seem to be informing me of something. The issue with comments is that, suppose I change this. It could still run, but the comment will be totally wrong. So what, you have to be vigilant about making sure your comments are up to date. I find that people are more interested in having comments than making sure they're up to date and correct. Otherwise, every time you change code, you have to go back through and change all your comments to make sure it's right? You have to at least review your comments. Who does that? Nobody. Nobody does that. Luckily, I think these comments are still correct, and I know what this code was intended to do. So what do we need that we don't have, right? So this code is going to minimize SOK minus K. Now, see, here's a good example. I'll bet you I extend this code even before, in the not too distant future, well before this stream is done, I'll bet you I extend this code and this comment will no longer be correct. And I'll just have to remember to do that. And that's not the easiest thing on earth to remember to do. Okay, so we're going to need S. We have W, but we need S. And what's the difference? So and of course we need S and its adjoint. Here, okay. Maybe, so where here D is the sampling mask. And K are the sample values that were collected. So K is equal to K data of sample mask, or of D. Sorry. Wow, we went through this before. I don't know if you guys remember. Is the complement of D. So here I'm thinking of this D matrix as a set of indices so that this is true. Well, not D matrix, just this D is a set of indices, a set of numbers such that this is true. So the data values that you collected, is equal to K data of D. Okay? Okay, this is all totally wrong. Let's try again. There's two Ks. K collected and K estimated. Okay? So K is equal to K collected union with K estimated. K here is the full, or all the K space values. If this is true, is this correct? Well, so, okay, so no, it's not correct because D now is a set. The set doesn't have an adjoint. But what I mean here is very doable. Like, I mean, in strict math notation, I want like the matrix here, D complement, I don't know. There should be a function here called 2 matrix. And this 2 matrix function is simple. It takes all the indices of D and isolates those rows of the identity matrix. That's the matrix. We then take its adjoint, and then we apply the SPIRiT kernel or whatever. And so the thing that we're minimizing over is K estimated. We're not going to change K collected. We're just going to change K estimated. By the way, we might in the future want to do this, subject to, so here K minus, or K of D minus K collected less than or equal to epsilon. So we'll change K, we'll even change the values of the K that were collected so that they're within a bound of noise. But we'll do that, if we do that, we'll do that later. Amongst other things, like right now, this can be solved with LSQR. This cannot. I'm pretty sure that can be solved with Vista, so no big deal, but I mean, nothing's a big deal, but we're going to start with LSQR. And we're just going to change K estimated. We're just the optimization variable is what I mean. Is the optimization variable would just be K estimated. For some reason, okay, now it works. Huh. I have to hit the mouse 3 times. Nope, that was 2. I don't know. Okay. And of course, we still don't have an image. Of course not. Thank you for reminding me of that, MATLAB. So, yeah. That's W. Once we have the fully sampled, once we have all the values in K space, right? Oh, so this should be, oh my gosh, this is very tough. Oh no, because that's okay, that's why this was S. Okay. But okay, so I want to actually put this in terms of W. Here's what I'm going to do. I can just go back to doing this. could put subject to here, but I'm not really thinking of this as a constraint. This is just like a definition. Okay, so K estimated is what we're going to that's the optimization variable. That's what we're going to ask the computer to give us, those values. Wow, I've already been at this for 25 minutes. Feels like I just got started. I find the most difficult part of streaming is having to wait to do stuff until I get a moment to stream. I often, let's say get inspired to do something on a project. And it's not always when I can stream. So I have an idea, I want to test it out, but I gotta wait. That's the toughest part in terms of making progress, I think. Okay. Equivalently, you want to minimize that's the identity matrix over K estimated. Now, so I need this in terms of like minimize AX minus B. That's what I'm trying to find here, okay? So what is W minus I? Well, that gets distributed over this, right? Plus thank you for your help, MATLAB. Okay, so this is wrong because this is just not the complement. Thank you for your help, MATLAB. Equivalently, minimize A K estimate minus B, where A and B are defined appropriately. This is A. And this is B. We need A. To make A, we're going to need the sample mask. We're going to store it in the three-dimensional array. That's not what we're doing. Okay, so in at this point in MATLAB is going to be just a vector, a one-dimensional array. This doesn't have to be zeros, I just need memory allocated. Okay, so the first thing I'm going to do is make B. Let's do that. Well, B is just equal to K data. No, B is just K data, right? This is K data. Okay, I'm clearly struggling here. Okay, so LSQR accepts both A and B. Of course it does. What else would it do? So I actually do need, so B is going to be this. This is just K data. Now, if you go back and look through the original SPIRiT code written, I think, by Lustig, he doesn't do this. Instead, he alters W to have a -1 at the corresponding locations. So instead of a 0 here, we could put a -1 there, and then this would be W minus I. When we applied this convolution kernel, it would be W minus I, which of course would be more efficient. Let's worry about that later. We worry about a lot of things later, don't we? Okay, so now this is A. As I said before, in here is a one-dimensional array in MATLAB. That's what's coming in. So here, for example, we could do B is equal to B, just make it a one-dimensional array. So here I'm putting the values of n into an array called k estimate of size the same as k data, everywhere where where samples are not collected, because n are this is the optimization variable. This is the thing that we're gonna, these are the estimates of our uncollected samples. So this here is actually this. And now, I think that's done. That is this matrix. That's the implementation of this matrix here. What on earth just happened? I don't think I changed anything. What on earth is happening? Okay, that was strange. I have no idea how I got here to the other function. Oh, I somehow closed recon spirit. And we need its adjoint. Okay, so the adjoint is this. The adjoint of W minus I is equal to the adjoint of W minus I, because the identity matrix is its own adjoint. So apply W just has two operations, good. Then we need the adjoint of this, and that is just we don't need that because the sample mask is already just ones. That might work. Let's find out. Nope. Array indices must be positive integers or logical values. What's the problem there? Logical values. Oh. So sample mask, I think, are logical values. Can we get this? There we go. Sample mask. Oh, it doesn't tell me what kind it is. Logical, right. So is 1 minus sample mask not logical values? How do I tell the type of a variable? Okay, temp is equal to 1 minus sample mask. Temp's in here already. Just need a variable name that's already in the static workplace. But what kind is it? Check W. It's double. Okay. MATLAB, take complement. What's the, like take not of logical values? Is there a not operation? Not A or not A. Okay. Did we do that anywhere else? Was it just that one location? Looks like it. Okay. Still crashes. Unable to perform assignment because left and right sides have different numbers of elements. Oh, of course. Okay, temp is equal to zeros, some sample mask 1. Rand is 1 I times n samples is equal to some sample mask. Okay. Still crashes. Different number of elements. Oh. Right. Okay, K estimated. What? Okay, no, that doesn't make sense, actually. Oh, wait. Yeah, okay. N not samples is equal to num L sample mask minus N samples. Is that the issue? This temp vector, oh. Yeah. Nope, that wasn't the issue. Let's call this K naught. Well, let's call this, I don't know, K naught's fine. And the thing is, so this matrix and this matrix take a different number of elements. This matrix accepts a vector of size equal to the number of samples collected, whereas this matrix accepts a vector of size equal to the number of samples to be estimated. So I call this not, I guess we could call this N estimated, which is the total number of samples in K-space that we're using minus the number of samples that were collected. K naught's empty. Why is that? Oh, what? What is M times N times C? M times N times C. Okay, that's a problem. Did I not undersample here? I didn't. Okay, not a problem. Not a problem. Here's code from a paper I just recently published. It creates sample masks. This is what we need now. Okay, so I'm going to create a new, this is now the code that runs the test. I'm going to set the sample fraction to 30%. So how many samples are we going to collect? N samples is equal to 0.3 times, oh no, it's sample fraction times here the number of samples is per coil. Okay. So it's going to be size of K data 1 times size of K data 2. And then what? We'll round that. Seems reasonable. Okay. Now this does not include an auto-calibration region. That's fine. Here the auto-calibration region was based on the wavelet transform. That's maybe what we'll do eventually. Oh, ACR mask. Okay, so now I need a size of an auto-calibration, which I already have. Great. So now I just need an auto-calibration region. Add data. Ones, SACR, SACR. I forget. Add the data to size N. Okay. That looks like an auto-calibration region. And then if we do this, ooh, it breaks. Why? S image. Where's S image? Okay. Just calling this ACR mask. This takes a second. It does a search to find all the different possible, well, it uses a code that I wrote to create a fast variable density Poisson disk mask. But when you create a fast variable density Poisson disk mask, you don't really have control over the number of samples. You only have control over this distance parameter. So this binary search is changing that distance parameter until the final sample mask has the right number of samples in it. And so there is a sample mask with a variable density Poisson disk sampling pattern on the outside and a fully sampled auto-calibration region on the inside. And this has 30% of the samples of the total number of samples. Great. So now K samples is just going to equal to, I'm going to take the K data, I'm going to multiply it by the sample mask. Okay? And eventually one day we'll get out an image and life will be good. So now K samples is not all the data. So when we get to here, oh goodness, okay. I don't want to wait for this to run every time, so I'm going to save it in an optimization, in a MATLAB variable again. Okay, so save stuff.mat, kdata, and sample mask. Let's delete kdata. Okay. Now we should be, what? Why? Not enough input arguments, of course not. I need to tell VSXFun what to do. Okay. Three, 6, 7,000. So the ratio of this to this should be about a half. Or wait, what? Oh, right, it should be about 2. Okay. And not quite 2, about 30% away from 2. Actually, about 30, a third away from 2. So that's about right. N to estimate divided by N estimate plus N samples is 0.7. Right. Okay. 0.3. Great. Now can we check the adjoint of A? Nope. Incompatible size for this operation. That's strange. Okay, one issue is I never used in here. Oh. Okay. When in doubt, just name things temp. What is this, the adjoint of this insertion operation here? Well, it's extraction. Shoot, I am not doing this well. Okay. Insertion comes before apply W, so apply W minus I. So on the other end, it's going to be apply W minus I and then extraction. Which I had already done. So I think this is just going to be in. There may be an issue here because this is outputting a three-dimensional array, and this is outputting the vector. And I don't know if LSQR can handle multi-dimensional arrays. I guess we're about to find out. This, of course, has nothing to do with, okay, so that's weird. Okay. So in is indeed the n by n by c. What's the size of applied W transpose to in? Whoa. What is the size of applied W to K estimate? Right. So what does this mean? The output of applied W should not be m by n by c, but m by n. So how can we even have an applied W? Minus I. I'm thinking about something totally wrong here. Let's say we had an index C. This is what we can do with W. So I have a few choices here. I can go through and store all the interpolation coefficients for all the coils, and then W minus I makes sense. Or I can take into account the indexing on this variable. How would I even take into account the indexing on that variable? Because for applyA, I guess I could have a variable of function scope called coil index, what this C is. Where does that C get used? There. Is that the right thing to do, or is it just right to do it all? Because then we would be minimizing the sum over C. This squared. So I still haven't, like to use LSQR, I'd still have to take into account the sum into the applyA function. Well, that answers that question. Looks like we're storing all the W's, kids. I could leave this as coil index as just C, but I want to change it to coil index to be more descriptive. And so if I go searching in the function for the variable, I don't have to control find C, which there are 126 of them, right? And we're back to that issue. Okay, so where does W get made? Here. But now apply W. Does that just work? That'll be a miracle if it just works. Looks like something broke. Apply W, right. And why did that break? Because this is now a 4-dimensional array, and that's a 3-dimensional array, and circconv2 seems to assume the same number of dimensions for both. Okay. So what do we do? For coil index equal to 1 to C. So this thinks I'm overwriting the variable of function scope. Does that matter? Yes. No. It doesn't matter right now because this variable, I'm not applying W in here. If I were, then this variable would be overwritten by these assignments. So in here, I guess I am just going to call this C just to make sure there's no conflicts in the future. Okay, so now apply W, I'll bet you works, but apply W transpose does not. Oh. So apply W transpose accepts a variable of size m by n by c and outputs a variable of size m by n by c by c. All right, let's see if the apply W check works or even runs. Apparently it doesn't. So W here has size, oh, it's a 4D array. Okay, this is just, what was I thinking? So W is a 4D array. Temp is undefined, but what is W? 4D array. The size of W is 5 by 5 by 5 by 8, or 5 by 5 by 8 by 8. So these are the coils, and this must be the kernel size. What is in? 256 by 256 by 8. Does in just go there? Clearly not. Okay, so this seems to be running now. This line runs. Right, these are the convolution kernel weights, W, that's why it's W. And are the k-space values that we're going to be applying the convolution to. What is in here? Oh, right, okay. We still need the adjoint of the sum operation. Okay. It looks like W. Wait, what? Oh, nope, never mind. Okay, what on earth is happening now? Oh, I'm in check adjoint. I don't want that. Why does it do that? I'm trying to set a breakpoint here. feel, and it's moving. Why is it doing that? Apply W. When I try to set a breakpoint, now it works. That was weird. When I was trying to set a breakpoint, it was just moving, shifting the window. About ready to go to Vim, but then how do you debug? I guess you could use the command line debugger with MATLAB. It is very nice to have this little arrow and be able to hover over variables. It's very nice. I might just have to do it. I don't know. We'll worry about that later. Do the circular convolution, then sum. So when we get to here for this, out is 256 by 256 by 8. Great. So when we get here, in is going to be what just happened. I just hit run. Okay. Oh, I thought we were already in apply W. Oh, we were in it because of this. Okay. Okay. So now in it should be 256 by 256 by 8. We're going to go through each coil individually. That's what's going to happen. For each coil, I'm going to look at just that slice of in and do the transpose of sum, which is the replicate the matrix. And then do the circular convolution, the transpose of the circular convolution with this. Why isn't that working? Okay. Okay, so this is check adjoint now. You input an array of size 256 by 256 by 8. When you apply W to that array, you get out something that's, is that right? Yes, that's 256 by 256 by 8. Okay. Why is 256 by 256 by 8? And when we're applying the adjoint, we're getting back a 4D array, and that is incorrect. And that is just because I set that variable incorrectly. Out should just be n by n by c. Still a problem. Let's see why that's happened. So F adjoint. Here we are at apply W. Out should be 256 by 256 by 8, but of course I'm indexing it incorrectly. And MATLAB grows arrays. Great. Okay. Do you run now? No. Oh, now it doesn't even. What? Okay, coming back here. So W index at a particular array, this is just going to be a 3D array. That is a 3D array. I'm going to do a circular convolution. It's 256 by 256 by 8. Okay, so something's going wrong. And I think the answer is this was supposed to be larger, and that okay, so then what comes out of this? No, this should be, okay, clearly I'm very confused. Let's start with just apply W. Apply W. For each coil, we just estimate the k-space values for that coil. That's what comes out, a three-dimensional array. So here, N is indeed a three-dimensional array. Now, what came into here? It should be a four-dimensional array. So we don't even get there now. Okay. So N is a four-dimensional array now, as it should. Wait. That doesn't make sense. The interpolation coefficients are a four-dimensional array, but the variable that gets passed in is just a three-dimensional array. Let's follow it through. Okay. Three-dimensional array goes in, three-dimensional array goes out. So I was right before. This does need to be a three-dimensional array. Whatever this is doing is incorrect. But I don't know what's wrong with this adjoint. We'll figure that out in a minute. Two 56 by 256 by 8. Great. Okay. I think this might need to be a sum, but I'm not sure yet. Not sure. I'm tired of guessing. I want to figure it out. All variables of N are used in each loop of each iteration of this loop. So each iterations of this loop are going to contribute to out. Still guessing. This one's pretty tough now. I didn't think it'd be this hard. Seems to run. Does it, or did it just crash? Yeah, it just crashed. It crashed at apply W. Okay. MATLAB can't handle the font of this window, so what I seem to need to do is increase with the pinch and zoom technique. But then if you do that, MATLAB can't figure out like that the window size is different. I think the issue is that there shouldn't, so this at least is going to fix the size problem, but I have no idea if that's correct or not. I'm at a breakpoint somewhere, okay. No, it won't fix the size problem. Why not? Because how could it? Okay, now the size problem is fixed. And it's true, right? So I did need the sum. I don't know that I really understand that, but it seems to be working. Okay, so now we're back to the spot. By the way, you remember I kept check W around, even though I said it wouldn't be used when we actually run the code. There's a good reason. I changed apply W, and I needed to check stuff again. Okay. No way. But because of that, applyA passed. So I think that's why, so I'm going to set a breakpoint here. Okay, sometimes when I set a breakpoint, it moves the window, and I think it's because I'm increasing the font size by zooming. But look at that, it gets through both checks. Yeah, let's just keep that around for a while. So what's applyA doing? This. Now, I don't know that we want B to be a vector. We might want it to be the multidimensional array. I guess we're going to find out. LSQR. applyA B. X star. And then let's call it K star. User supplied function failed. Doc LSQR. AB, let's see. That's the first one with X naught. One, two, three, four. Wait, what did I just count? 1, 2, 3, 4, 5, 6, 7. The seventh one is X naught. Okay. 1, 2, 3, 4, 5, 6, K naught. And we'll just pass in the data for K naught. How about that? Oh. No. Okay, so K naught. K naught is equal to zeros K estimate by 1. Right? Aren't I doing that? Yes. Undefined variable K estimate. Oh, I needed N estimate, not K estimate. And that means I need this outside. Rank deficient rank. So I know that LSQR can accept a vector. How long have we been at this? An hour and a half. This is a long one. Do we keep going or do we leave it here? What I don't know if it, so right now applyA is outputting a matrix, right? So I could do this. I can do this. The issue is then I then need to take that into account here. I don't remember what this dimension is, but I'm guessing it's n by n by c. Let's see if see if we broke A. Nope, still passes. Okay. Let's see if that was the issue. It was not. Arrays have incompatible sizes for this operation, LSQR. So this is now MATLAB code. Let's put a breakpoint here. A function is apply A type is function, X is n something, I'll bet. Let's find out. So we're going to go in here. If it's a matrix, it is not a matrix. See now for, okay. We're going to pass X into A function to get Y. What size is Y? 524288. That's the size of K-space that we're, of sampled K-space, let's call it. Okay, what size is U? U is the size of B. Right. What size is B? Why, when I set that, see what's happening? I tried to set a breakpoint, then it moves the window, shifts the window. I just want to set a breakpoint now. Size. That should be 256 by 256. Yeah, right. So what just happened down here? For some reason now when I step, the window doesn't move with the step. B should be the right size. Do I still have a breakpoint here? I do. just to be sure, like I'm passing B here. Oh, look, B is getting overwritten in this loop. This is a totally different A and B. Okay. So I'm going to say, so this is going to be Y. Y now. Maybe I'll make this Y here. Yeah, now use the right size. LSQR ran. It ran successfully. K star is equal to reshape K star M by N by C. Image is equal to my recon roamer, my recon IFFT, K star, not start. What did I say? I just want to do in the first and second dimensions, right? We're not going to do an FFT in the third dimension. Is that actually a reasonably looking image? That would shock me. And it's not a reasonably looking image. Okay, why not? Oh. Three, 6, 7. Right. These are just the estimates, just the estimated values. We need that. Okay. K out is equal to K data. K out, not sample mask is equal to K star. Huh. There are issues. That looks like an ankle. Part of the issue is that I should never have done a variable density sample mask. sample mask 1, 2, 2 to end, go to 0. Sample mask equals sample mask or ACR mask. Will that work? This is the sort of thing that SPIRiT was intended to handle, just regular undersampling. Well, that looks like aliasing, doesn't it? That looks terrible. So there's a problem. And I currently have no idea what it is. Is it just the size of the ACR mask? What if we did, I don't know, 51? It's better. It's a pretty large ACR. That seems like it would be reasonable for SPIRiT to work. Okay, it seems like something's going wrong. And it seems like something's going right. Right? What if I just reconstructed oh no, things are just going wrong. It's better when we just use the zero filled image. Okay. We got really far. We seem to have an applyA and applyW that are working, and LSQR is running. So that's good. I'm going to take a break. We'll see what happens the next time I do this. I look forward to making a good image, though. Let's send this back to 17. That image is terrible. All right. See you guys next time. We're getting closer.